All right, so let's do this transistor amplifier problem. This is a transistor in a common emitter configuration, and the problem says a signal voltage of 550 millivolts RMS is applied to the base. So determine the output signal voltage for the amplifier. So that is the first thing that we need to do. Output signal first, in order to calculate that, we need to find the gain of the amplifier. So the gain is RC over RE, resistor of the collector over resistor of the emitter. So that is 10K over 1K equals 10. That is the gain of the amplifier. So the output voltage, V out, is equals to the gain times the input voltage. So this will be equals to 10 times 100 millivolts. Actually, it is 50 millivolts, not 500 millivolts. $50 millivolts, and it is 500 millivolts on the output. This is RMS. V out is 500 millivolts. Next, find the DC collector voltage on which the output signal voltage is riding. We have an input voltage here, and we have the output in this case is taken from the collector. We need to find the voltage at this point. Actually, no, we need to find the voltage drop. We need to find the DC collector voltage on which the output voltage is riding. First, we need to find the voltage at this point, the DC voltage. So we can say voltage at the base is equals to VCC times R2 over R1 plus R2. This is equals to 25 VCC, the voltage of the power supply, times they're both kilo ohms, so I'm going to say 4.7 over 4.7 plus 47, and this is equals to 2.27 volts. Next, let's calculate what is the voltage and current on the emitter. Voltage on the emitter is equals to voltage on the base minus 0.6 volts. Let's make it 0.7. 0.7. So this is equals to 2.27 minus 0.7, and this is equals to minus 0.7, 157. Now let's calculate the current flowing through the emitter. And that is equals to voltage on the emitter over the resistance of the emitter. This equals 1.57 volts over 1 kilo ohm. That's 1 times 10 to the 3 minus, and this is equals to 1.57 milliamps. We can say that the current of the collector, is approximately equal to the current on the emitter. And that is equals to 1.57 milliamps. Okay? So this current flowing here is approximately 1.7 milliamps. So what is the voltage? Voltage of the collector is equals to VCC minus the voltage drop across the resistor of the resistor of the collector, which is 1.57 milliamps times 10 to the minus 3 times 10 times 10 to the 3. And that is 15 volts. So this is equals to 25 minus 15 equals 10 volts. The voltage of the collector, this voltage right here, VDC equals 10 volts. So finally say draw the output waveform. So the output waveform should look something like this. Let's say that this here is 10 volts DC current. So if our output signal is 500 millivolts and is riding on top of the 10 volts DC power supply, it'll go 500 millivolts positive, so to 10.5, and it'll go down to 9.5. So it looks something like this. All right. So that is the video, and thanks for watching.